Hello, my name is Dr. Simon Schmidt. I'm head of the Department of Hygrothermics at the Fraunhofer Institute for Building Physics, and I welcome you to another video about the Lighthouse project in RAJKOT, where we look at the monolithic concrete construction using tunnel formwork as you are using it in RAJKOT itself. Within this video, we will look at the energy efficiency enhancements that we can take into account and that we can do within that RAJKOT construction. This video is structured as follows. First, we are looking at the definition of energy efficiency and one example of how to display the energy efficiency balance in such a project. We will also look in different steps of enhancing the energy efficiency. And in the end, we will look at the construction itself and see what major influences we have and what major possibilities we have in order to optimize and enhance the energy efficiency of that construction. By the end of the video, you will have learned how to go through that process in a very brief way. And I'm looking forward that you are asking questions in the chat or somewhere else. Let's start with the definition of energy efficiency enhancement. And first of all, I would like to bring up a definition of efficiency. Efficiency itself means achieving the best possible benefit with the least possible effort. So what we have to do is finding out what is the best possible benefit that we will get out of it, and then we try to put in as less as possible to achieve that. In our area, it's the best possible benefit, the least energy that we are using for the use phase of that building, and we try to do that with the best efforts that we have. In one of another videos that I've shown in Chennai, which you could also look for the Lighthouse Project 1, I have explained this balancing basic, this graphical display. On the one hand side, I have explained how this equation up here is structured and then how we can display that. As we are using that also in this video, I have brought that up again. Basically, what we are doing is we're summing up all the sources, energy sources, to a certain building, and on the other hand side, summing up all the sinks, energy sinks, for a certain building. The missing part then, in our case, is the cooling demand that we have to put into or take out of that system. This is what we like to reduce to a minimum with the least possible effort. How to do that is the question, and this is also what we are doing in the next few slides. So the question is steps to energy efficient buildings. How do we do that? And I have brought you really 3 steps in order to bringing that to real life. The first is that we always start with is we have to calculate the energy demand for the actual design. So there has to be some kind of design which we can use to calculate the sinks and sources. We can do that by manual calculation if we are on a very early stage of design, or we're doing that with computer calculations, Excel sheets or thermal simulation tools in a later stage. You can see a picture down here where there is a later stage and you can see some kind of analysis out of that in that. And it's not important with what and how you do it. It's just important that you get the results of that calculation, because that is the basis for the next step. If you have done that, you will get some results out of it and you can evaluate these results. So the next step is evaluate the most important sinks and or sources that you can change, which mean normally we do a graphical display of the sinks and sources as I've showed you before, or as you have seen it down here, and then we can evaluate, in this case, the sources on top and the sinks on the bottom, the major sources, and select the largest one by one, and going to the next step. If we have found out what is the major source or major sink, we can then adapt this. In this case, example, the solar radiation is the main source that we have. So what we can do now is adapt that. For example, we have a window which has no sunscreen. We can add a sunscreen. You have just to look at and also discuss with the architects and with the other customers or stakeholders in that area what is feasible and what is not. So the adaptance have to stay within the design constraints. If you can do that, then restart with the point 1. So after you have changed that construction, after you have changed that, you recalculate and again go through the steps again. As it's mostly not the easiest thing to do something and in the step 3, I have also introduced one slide where I will go through some possibilities in order to reduce the energy demand, some design options. For examples, if you are on the solar gains source side, mostly source sides, you can go through the solar shading as we have done before. You could also use different windows with a lower G value or brighter colors on the outside, as we have seen in the first video or in the second video that I've shown you. Next step then could be the heat transmission. So all the opaque building components, you can use insulation here, you can use another material which has another heat conductivity, or you can also reduce the heat bridges if there are any. Another source which is always there is also the internal gains. The pity about that is that you mostly cannot change that a lot, because that is mostly a design parameter. A building is built for the people, and the energy from the people comes out of themselves and they have to go into that building. Also, if there is a computer room or something like that, you normally cannot change that parameter. You can look at it, but you cannot change. On the other hand side, for example, the heat sinks could be the ventilation. And you can change that by using night ventilation, so making it from a sink to a source, or using that sink possibly, or introducing a heat recovery ventilation, or even reduce the leakages. And by doing that, one example of that for the heat transfer, you can reduce the sources and sinks by, as this example shows, up to 85%. So there are different possibilities, and these are just some of them you can use. But now you ask, what could I do for the RAJKOT construction? To answer this, I've gone through to the 3 steps I've showed you before. So the first step was, as you remember, calculating the basic construction. So what I have done is, I've used the basic layout of one of the flats and calculated it using a thermal simulation program. Out of that, I derived the different energy sinks and sources, and I displayed it in a graphical way. So you can see here on the left-hand side the sources, which is the internal sources, the solar sources and the heat transmission. And on the other hand side the sinks, which is the ventilation sink and the cooling demand that we actually have, which is around about 4,000 kilowatt hours per year for that flat. So the second step, as I told you, was to find the highest energy amount that we have and try to change that. What I have done here is now I found that the solar gains are the main source that we have. And the second source, I also included that step by step, one by one, that also the heat transmission is quite a huge source. I have recalculated it for the solar, introducing a solar shading. I have also recalculated it using less heat bridges and introducing a light color on the outside and also an insulation on the outside to reduce this, and have recalculated it, and you will see what happens in the next slide. So what I have done is first reduction of the solar gains by using solar shading. Second, reduction of the heat transmission by using insulation, white color on the outside, and reduction of the heat bridges. And then we come to that point where we see that the heat sources from solar gains are reduced to 1.6 thousand kilowatt hours per year, and the heat transmission is almost zero. On the other hand side, we see that the cooling demand is now from 4,000 kilowatt hours per year down to 1.75 or 1.8 thousand kilowatt hours per year, which is quite a huge amount. And now we could go even further and say, okay, there are still the sinks. We could introduce the sinks so that they are possibly helping us reducing the cooling demand by introducing night ventilation or other ideas in that area. I haven't done that, but I have summarized what I have done. So the first thing I have done is introducing a solar radiation shield. But I come from another side because we're discussing also the different areas on the outside and inside. So if we just put on bright colors on the outside, we are able to reduce the energy demand up to 12% for that special construction. If we then introduce insulation on the outside, we can add another 12.5 or 13%, so that we have a combined reduction of up to 25%. So this is what we can do with the heat transmission reduction by using bright colors on the outside and insulation on the inside or outside. And if we then go to the solar radiation and reduce the solar radiation by introducing some solar shading, we can further reduce that amount up to 54%. So it's more than half of the cooling demand that we can reduce by just going through these 3 steps. So first, calculate the basic construction. Second, find the highest sinks and sources and optimize them in order to reduce the energy you need and reduce the energy demand. What I would like to add in the end is that bright colors have quite a high impact, but depending on where they are and how the outside is, this effect can go to zero by the pollution, because bright colors tend to go dark again by pollution. So this first 12% that you have here may occur in the beginning, but then are reduced later on. So we have to look at that design, especially if we have bright colors on the outside. And with that, I would like to thank you for listening, and I hope that you can do these 3 steps over and over again to reduce the energy demand of your buildings, and especially for the construction in RAJKOT, and say goodbye to the next time.